Hello viewers, welcome back to our YouTube channel, Maths with Ras. In today's session, we are going to look at the Pythagorean identities. There are three Pythagorean identities that we are going to look at how to prove them. Now let's take into consideration this right angle triangle. Now, let's assume this is x and y here, which falls on the y-axis, and then r here, that is the distance from this side. So let me name my right angle triangle A, B, C. So r being the distance from B to C. Now, when you have a right angle triangle, as already discussed in our previous videos, where angle theta faces is the opposite, and where the angle 90 degrees faces, that is the longest side of the right angle triangle, is the hypotenuse, and the other side being the adjacent. Now, in our previous videos, we look at trigonometric functions. The first three trigonometric functions, which is the sine, the cosine, and the tangent. Now, from this right angle triangle, we should find the three trigonometric functions. That is, we are going to find the sine of the angle given here, which is theta. So we have sine theta, and we know sine theta is opposite over hypotenuse. So in this case, our opposite is y, hypotenuse being r. And to find the cos of the angle given, cos is adjacent over hypotenuse. So our adjacent here is x, and the hypotenuse being r. And then last, we find the last function, which is the tan function, which is opposite over adjacent. So opposite being y, and the adjacent being x. Good. Again, we are going to consider the Pythagoras theorem, which says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is the opposite and the adjacent. So the square of the hypotenuse, and we know this is the hypotenuse, which is r. So the square of the hypotenuse, which is r squared, is equal to the sum of the squares of the other two sides, which is the adjacent and the opposite. That is x squared plus y squared. And I'll name this one equation 1. Now from the equation 1, let's divide through by r squared. In this case, we are going to prove the Pythagorean identities as I mentioned earlier. So we are going to divide through by r squared. Now, if we should divide through by r squared, that means we are going to have r squared divided by r squared, which is equal to s squared on s squared plus y squared on r squared. Now, clearly we can see that r squared cancels r squared, so we have 1, which is equal to, this one can be written as x on r all squared, plus the same way I can write this as y on r all squared. Now we have 1 is equal to, now we have x on r, and from our trigonometric function, where do we find x on r? It is the cosine or the cos function, which is x on r. So in place of x on r, we are going to replace it by the cos theta. So we have 1 is equal to, now cos theta squared, plus we have y on r. Which of the function has y on r? It is a sine function, which is y on r. So in place of y on r, we replace it by sine theta. So we have sine theta squared. Now we have 1 is equal to cos theta squared, which is cos squared theta, plus sine theta squared, which is sine squared theta. Now this gives us our first Pythagorean identity, which is sine squared theta plus cos squared theta, which is equal to 1. That is the first Pythagorean identity. Again, we are going to consider the first equation that I wrote here, which is r squared is equal to s squared plus y squared. Now in this case, we are going to divide through by s squared. With the first one, we divided through by r squared. So in this case, we are going to divide through by x squared. That means we are going to have r squared on x squared, which is equal to s squared on x squared plus y squared on x squared. Now clearly, I can write this one as r on x all squared, which is equal to x squared cancels s squared, so 1 plus, this can be written as y on x all squared. Then we come back to our trigonometric functions. Now, which of the functions has or gives us r on x? Now, in this case, we have x on r, not r on x. But we know, or we learned in our previous videos, that when we reciprocate the cos function, we are getting the secant. That's the sec function. So instead of x on r being cos theta, so the reciprocal of the cos function being r on x is the sec function. In this case, we have sec theta squared, which is equal to 1 plus. Now we come back to our function, we have y on x. Which of the function here gives us y on x? It is the tan function which gives us y on x. So in place of y on x, then we replace it by the tan theta. So we have tan theta all squared. So we can simplify it as sec squared theta, which is equal to 1 plus tan squared theta. So this gives us our second Pythagorean identity. Now the last Pythagorean identity, we are still going to consider the first equation. With the last one, we are going to divide through by y squared. Now when you divide through by y squared, it means you are getting r squared on y squared, which is equal to x squared on y squared plus y squared on y squared. Now this can be written as r on y all squared plus x on y all squared plus 1. Now we come back to our trigonometric functions. We have r on y. So which of the functions gives us r on y? But in this case, we have y on r, but we are looking for r on y. This clearly tells us that r on y is the reciprocal of the sine function. Now, the reciprocal of the sine function is the cosec function. In this case, r on y is going to be cosec theta squared plus x on y. Now, x on y, we are not having x on y, but rather we have y on x. That means the inverse of the tan function, which is the cotangent. So that is the cot theta all squared plus 1. Now the cosec squared or cosec theta squared is cosec squared theta plus we have cot squared theta plus 1. And this gives us, so I have my equal sign here, equal sign. So cosec squared theta is equal to cot squared theta plus 1. And these are the three Pythagorean identities. The first one is sine squared theta plus cos squared theta is equal to 1. And then sec squared theta is equal to 1 plus tan squared theta. And the third Pythagorean identity is cosec squared theta is equal to cot squared theta plus 1. Thank you.